Hey everybody, it's Mr. Carr again. Today we're going to be talking about 7C Day 1, factoring using what's called the GCF or greatest common factor. So let's talk about what factoring is before we get into that. Factoring is our way of undoing distribution. Okay, so think about how you started with some of our distribution. If I took x times x plus 5, you are taking that, multiplying it there, so it turns into this, x squared plus 5x. Factoring means I'm just taking this expression, I'm going to turn it back into this version. We're going to go reverse this process. We're going to go undo our distribution. In order to do that, today we're going to be focusing on GCF. You've done this before. You did this all the way back in unit 1, and we did that with just numbers. Okay, so we said that was the largest, okay, numerical, or, well, let me see this, and or variable factor in every term. Okay, so the greatest common factor is the largest number and or variable, because sometimes you might be dealing with just the numbers or just the variables, just depends on the scenario. So we think about things that have in common. It's a fun little game here. So try to figure these out. If you want to pause the video real fast, see if you can answer all three of these. Okay, to be honest, the first one threw me off a little bit. So picnic, card, and pool, what do these all three have in common? They are all tables. Yeah. Days, continents, and seas. There are 7 of these. And I was not planning on rhyming, but I did. Okay. Stream, kidney, and green. They're all beans. All right. So just thinking about what do they have in common? So let's see if we can tie that to this. Determine the GCF between the given expressions, 28 and 42. Again, this was one that you did in the past. For helping with these numbers, think about what factors there are for each of these. So for example, 28, you can do 1 times 28, you can do 2 times 14, and you can do 3, that won't work, but then we go 4 and 7. That works. Okay. 42. I've got 1 and I'll give myself a little more space, 1 and 42, 2 and 21, 3 and 14, I believe. And a little bit more space, and then the last two are going to be 6 and 7. Okay, so this is what we did back in unit 1. The greatest common would be, if I kind of look at it from right to left, I see 14 here and 14 here. There are other common factors, but the greatest common factor here is 14. Kind of similar to that, but when we look at with these variables on there as well, between these two expressions, so 7 and 21, first thing is, let's look at the numbers. What's the GCF for 7 and 21? That one's actually pretty easy because, whoa, hello, didn't want to do that. All right, fix that. Okay, so 7 and 21, the GCF is just 7. One thing that's always helpful is, can the smaller number go into the bigger number? 7 does go into 21, so my GCF does have 7 there. But now let's look at the other parts. We've got x and x to the 4th. So if you think about it, remember, x to the 4th is this multiplication here. The only factor they have is a single x. We look at the smaller exponent, that many x's are at least in the x to the 4th. So x will be in my GCF here. Then I'm comparing y squared and y. Remember, this is y times y. So this is just a y here. So since I have a single y here, I got a single y in my GCF. It's always going to be the smaller exponents when we start talking about variables. Okay, so for part C here, 30 and 60, again, 30 can go into 60, so that's going to be my greatest common factor. We got m squared and m squared. They actually just have m squared in common. And then n and n, so I have n in common. That was pretty straightforward. Negative 5a and 10a squared. So we can take out, well, for GCF, well, this one can go either way, but I can do a 5, or I could do a negative 5. Then I look at a and a squared. I could take an a out of either one of those. I cannot take a squared out of both because that's too big for the first one. All right, so again, always smaller exponent. For our processes today, always take out a leading, okay, coefficient that is negative, okay? So whenever your leading coefficient is negative, we would do something like this. We would take out a negative 5a instead of just a positive 5a. All right, so that's what we're gonna look at here. Determine the GCF and use it to factor. So remember when I said factor is the reverse, we are undoing distribution. So I like to think of it this way. I like to try to use the distribution kind of a little bit backwards here. First thing I'm gonna do is I'm gonna identify the GCF. 15 and 25. For the numbers, that's just 5. Okay, 5 goes into 15, 5 goes into 25. Then I look at x and x squared. It's an x that can come out of both of them. So when I do my factoring, so step 1, I need to identify the GCF. Step 2, I'm now going to rewrite everything with the GCF in front. So it's going to look like this. It's going to be 5x times something. Well, remember what I have. I have 2 terms here. So that means my factor form, I'm also going to have 2 terms. So I like to think of it this way. 5x is got to be multiplied by something to give me to 15x. The only way for me to do that is if this was a 3. Same thing here. 5x times this has to get me to 25x squared. Well, since it's an x and it gets up to an x squared, I have an x here. Then 5 times 5 is going to give me that. And that's my factored form. Okay, so for part B here, we're going to do the same thing. My leading coefficient is going to be right here. It's negative 30. So I'm going to take out for my GCF. It is going to be a negative. I've got negative 30, negative 12, and a positive 24. That should be 6. So we're going to take out a negative 6 from everything. X, we got x to the first, x to the first, x squared. So I can take out just a single x. Then we got y, y squared, y to the fourth. I can just take out a single y because that's the smallest one. All right, so step 1 is done. Step 2, let's rewrite this. So negative 6xy. From this one, I've got negative 6 would be multiplied by a positive 2. And then x and y would just multiply by nothing. In this case, it would just still be multiplied by that 2. So that's actually done. Okay, since I'm taking out a negative here, and this is a positive, the only way for that to work, remember, I'm thinking about this in terms of distribution. This times something gives me a positive 24. So that means my number inside the parentheses is going to be negative. So negative 6 times negative 4 gives me a positive 24. X is going to go to x to the first, so that actually stays the same. But y needs to be multiplied by another y for me to get y squared. Okay, again, I'm just comparing to this middle term here. So I can double check, does this times this give me this? And it does. Okay, negative here, so that's actually gonna be a positive. Negative 6 has got to be multiplied by a positive 5 to get to negative 30. X and x squared, that needs to be an x to make this work out. And then y and y to the 4, so that's gonna be y to the third power. Okay, and that's our factoring with our GCF there. Oh, yeah, I just did all the work there, but whatever, it's fine. Okay, you can see that. There's my GCF, should have been written here. There's my final factored form down here. Okay. Okay. So that's it for 7C day 1. This is our beginning of factoring. We're going to move on to some more complicated versions of this. But remember, the biggest thing I want you to take from this is that when I do factoring, we're undoing distribution. That's the goal here. Try to always think about the backwards version of distribution is the goal. All right. That's it for today. Take care.